So let's learn how to program ATmega32 in Proteus.
Welcome to the Mechatronics Mind, where hardware meets software, powered by curiosity. Let's build something extraordinary.
Okay, so hello guys, welcome. It's been months that I have ever made a video, so in today's video I'm gonna introduce you with ATmel Studio, Proteus and ATmega32 microcontroller. Okay, so first of all I have opened Proteus and we'll start with a new project. Okay, let's say this be P1. Okay, here you can see it's in here, and this one says about libraries. Okay, so let me search for ATmega32. This one is an AVR board, and it includes 32 kilobytes of ROM and 2 kilobytes of RAM and 1 kilobyte of EEPROM. Okay, you can see the board, and it's about, it has 44 pins of total, and there are only 32 input output pins, and you can see this part is called port C, this one is port D, this one is port A, and this one is port B. Okay, so to run this, to check it, I'm gonna take some LEDs. Let's say LED. Okay, okay, you can see there's some bar graph, and bar graph includes 10 LEDs alongside. Okay, so I'm using this because I love compact things. Wait, before using bar graphs, you should take some specifications. Like there are some LEDs or displays we use common cathode and common anode. Whatever, this doesn't have that kind of specifications. Okay, so you can use it. Okay, here I have shorted all of these grounds, and so now I'll need power cable, which needs to be power from here, and again I need a ground. Okay, this needs to be power from here. Okay, so now I'll need to control it, and to do that I'll need to include an hex file here. Okay, you can see a program file. So to program an ATmega, I'll need to provide an hex file, and we can generate hex file using many ways, but assembly language is better option, but assembly language is too complex, so instead of that I'm going to use C programming language. Okay, you can see this is my starting page for ATmel Studio, and I'm going to use new project, and as I'm going to execute the files, so I'm going to use GCC C executable project. Again, I will need to select the board. Okay. This is my real name, whatever. Okay. Here let's start with AVR input output .h with a library. I'm gonna code this one. Okay. So make it hard display. Okay. Okay, now it's fine. So first of all, I'll need to use this one. This is called port C. So to do that, I'll need to do a registry. So include DDR C. That means data direction registry towards port C. Okay. So as I will need to add all of this, I can use 0xFF. Okay, 0xFF, which means as I already said, you can see here are 8 bits. That means 8 pins. So all of the pin members are 111, 111. That means all are set to output. So basically what DDRC do, you just set an pin number to an input or output. Okay, now let me show an input file. Okay, port. Okay, so I'm gonna output. Okay, let's say I will light up LEDs on 1, 3, 4, 6, 7. Okay, so 1, and for pin number, and for pin 3, it should be 0. Again, pin 4, let it also 0. Again, it's 1, 0, 1. Let's say it be 1, 0, 1, 0. Okay. Let's include another. Okay, as I am using binary number, so I'll need to add this one 0b. Okay. Okay, so let's run this one. As I don't have any port, so it wouldn't message whatever. So run through this one. Okay, you can see build successfully. Okay, and if you move forward, you can see there is an task complete. Okay, wait, from project. When you see this line, just copy. Okay, go for File Explorer, and then paste here. Okay, after that you'll see this one is the main file you have just built. So go to debug, and you can see here is a hex file. Just copy as path. Okay, this thing. I'm new to Windows 10, so I'm just facing some problems. Whatever, just paste. Okay, again. Okay, so now let's run it. Okay, it's showing fatal because I didn't remove these things. Okay, you can see it light up the PC0, PC1, PC4, and PC7. We can try another method of pointing to data direction register and the output register. Okay, so let me try with number 7. Basically, in binary, 7 means 0, 0, 0, 0, all others are 1. So now if we try this, I think we can light up these LEDs. Okay, so this is called PC7 and PC4. Okay, so let's upload this one. After uploading this one, let's try it. You can see these LEDs haven't light up, but you can see there is a signal, but they are not ready to take outputs, ready to provide outputs. Okay, whatever. Okay, you can also try this one with let me try with 5. Okay, 5 in binary is 0, 0, 0, 0, 1, 0, 1. Maybe you can see it's 1, 0, 1. Okay. So let's try to light up all LEDs in another way. Okay, let's give 0xFF. That means I'll need to what's that? Okay, let me light up all LEDs. Okay, so let's try it. Int x equals to 1. Let's start from 0. X is smaller than 255. Why do you 55? Because it's 8-bit. 8-bit means 2 to the power 8, which is equals to 255. That means it can take 255 combinations of 0 and 1. Okay. Let's say port C equals to X. Okay, There is a problem because for loop executes in milliseconds, so you don't see the transitions. Okay, so to see the transitions, I'll need to add a few things like hash include util per delay. That means to use delay, I'll need to add its library. Okay, again to include delay, I'll need to add CPU speed. Okay, so let's define it. Hash define if CPU and its speed be 8 megahertz. Okay, so 8, and for mega I'll need to add 6 zeros, 3. Okay, 6 zeros, and at the last I'll need to use eval. Okay, now let's add delay ns, then let it be 200 millisecond or 0.2 second. Okay, now let's see. Okay, 1, it's too slow. Let this be 50. Okay, you can see it. And that's do nothing, just to show us the number systems. Okay, so now let's try to control this one. Okay, so here are only, what's this, only 8 LEDs. Okay, let's try with 8, and okay, let's add AYMT. Okay, unsigned 8-bit integer D. Okay, it's done. Let's see what happens. I guess it won't go more. So 255 is a better option. Okay. So what I want to do is, if so, I want to just stop this thing. Okay, let's, whenever this compiler wants to light up the LED 3, it will stop. Okay, so to do that, I will need to know what is the input, or what is the input from this thing. Okay, so input is taken using pin C. So, okay, so if pin C, that means if this pin number 3 is on, wait, yes, if pin C, and then one left shift register to PC 3. So, if it does, let's say all of the LEDs will be off. So let's try with hexadecimal number 00 off for, let's say, 100 milliseconds. Okay. Okay, what this thing does is basically PC3 is just pin numbers. You can see here, this is PC3. You can directly use it in the compiler. Okay, so PC3 means in pin C, it says about the output. Okay. 0, 0, 0, 0, 0, 1. Sorry, PC3, that means fourth number pin, right? Yeah. So this thing. Okay, so basically pin C. So if 1 is output and PC3 is on, okay, so all of the LEDs will be turned off. Okay, so let's try this. You can see all are off. You can see it's getting off, and it's really annoying. Okay, so stop it. Okay, now you can do the same thing using another LEDs and other things. Okay, so let me take another LED. Because I'm busy. I'm busy. Okay, so now let's try to use PD3 and it will turn on whenever this will be off. Okay, so to do that I'll need to add port D as output. Okay, let's say DDRD. Okay, let's say only PD3 will be on. Okay, so 0B 000 0 PD3, that means port pin. Okay, 1000. Okay, so if it does, port D will be on. Let's say 0xFF. Okay, now let's see what happens. Use this thing. You can see whenever the port 4 off, there's something I must add. After the delay, port D will be off. Or so now let's do something more. Okay, before going to another level, I will just fix some of things like DDS. Into the oh, okay. Let's say what's that? PNC. Okay, PNC defines the stage of a sorry, it's not a stage but it's state of a pin. Likely, it defines if the pin C is turned on, pin PC3 is on, whatever, and PC3 defines the pin number. Again, port C is basically output. So when you give an output, it's a high voltage. That means only a 5-volt output. And if PC3 or whatever, if your output is 0, then the output voltage is also 0. Okay, so that's all for these things. And now I'm gonna try with 7-segment LED display.